Good afternoon, everyone. My name is Michael Geraci, and I'm an intern with the Azure networking team here at Microsoft. Today, I'm excited to share with you some changes to the real-time operations checker, specifically on the user interface side of things. So without further ado, what is the real-time operations checker, or ROC? Well, ROC is a tool in which any change to network topology, such as network maintenance, traffic migration scenarios, growing the network, or adding demand or topology to the network, can be tested for safety, therefore reducing risk on the network. So with ROC, you really don't ever have to wonder what would happen to the network if something were to change, if a router or link were to be cut or go down. You can always see the results of it. So the first thing someone would want to do if they were to use ROC is to create a set of changes to the network topology. And we can do that via the new jobs page. So on this page, we are presented with a bunch of UI options, and let's go over each one of these. The first is the network type. We have core, which is our old network, and swan, which is our newer network. So today, let's carry out these network topology changes on core. Furthermore, we have a date range. So we can select a date and a duration to carry out this network topology changes. If we select something in the future, up to a week in the future, we'll actually use machine learning to dictate how much demand will be at the network at that time. So for this time, let's specify a day in the future from the date picker. And let's specify the hour of 1 p.m. or sorry, 1 a.m. UTC. We can also specify a duration in number of hours, so a time window. So if we want to see how the demand of the network changes over a duration of time, we can select that too. So let's select 2 hours for this. Now we see an interval. We can only select hourly at the minute. Now before, when we wanted to enter change request commands, we'd have to manually enter the commands in this box like so. But we no longer have to do that. Instead, we can click add a new command, and we're presented an intuitive interface where we can add new change request commands. The first field we'll see here is the command name, and this is the type of action we'd want to perform on the network topology. So if we'd wanted to add a link, all we'd have to do is click add link. We'd be presented with the appropriate fields for adding a link, such as the source router and destination router to add the link between. In this case, let's select these source and destination routers. Furthermore, we'd need to specify an interface for these source and destination routers to connect between. So in this case, we'll do test. Finally, we can specify a bandwidth in megabits per second. In this case, let's specify 10 gigabits per second. We can also specify a metric, which is essentially the weight of the link. Let's do 100 in this case. And furthermore, we can add additional constraints such as admin groups or shared risk groups. In this case, let's add this to shared risk group 1. Finally, we can see the output of our CRC command in this box to see everything that we just input and what the output command looks like. And we can click save. Now the output command is added to the change request commands list. We can go ahead and do this for other actions. So let's add a demand. Once again, we can select a source router and a destination router. And we notice that the source region and destination regions are auto-filled. Furthermore, we can specify the amount of megabits per second of this new demand. So let's specify 1 gigabit per second. The application, which is really just a comments field. So for in this case, we could put Skype or Exchange or whatever, and it is just essentially a note. And also a traffic class. Now in traffic class, we have best effort and scavenger, where best effort is priority traffic that we'd prefer not to drop, and scavenger is traffic which might be able to be dropped and is less priority. Finally, we see the output of the change request command again, and we can save this change request command. Let's add one more. We can also remove routers and perform all of these other commands. So to remove a router, we can just select a router from this list. Note that we can also type into this list to autofill and select ones with matching names. So if we wanted to remove a router in the Bay Area, we can simply do that by typing Bay and selecting one of these. Once again, we see our output command and we can save it. Now this is all great, but for new users of this, they might not know where the routers are located or the links are located, or the names of either of these things. So there's also a very easy and intuitive to use interface if we click add a new command by switching over from basic mode to map mode. So we do that by clicking the switch at the top. Now we're going to be presented with a new interface, and we can select our commands just as before. If we need any help on this page, we can click the Help button, which is going to guide us through an entire tutorial about how to use the map interface. For now, let's remove a link. We can simply select Remove Link, go to a specific link. In this case, let's check out how Australia is doing, and remove a link between Australia and another country. We notice that all we have to do is click the link itself. All the information regarding the source interface and destination interface is automatically filled in, and we see our output command here. We can save this just as before, and we note that it is added to the change request commands box. Finally, we have a few more options. We have the SWAN configuration option, which allows us to choose a SWAN configuration, but in this case, we're in the core network type. We can also add some comments. So we can add a comment here. This just allows us to visually and distinctively differentiate between our different change request command sets. Finally, we can go to advanced options, and we can specify additional failure scenarios as well as different result types. For now, let's just keep this default and let's submit this job. So now the job is submitting, and it'll bring us over to the My Jobs page. While the job will take time to run, there are different parameters which are important about this job. Specifically, I want to highlight the cut check safety, the SPOF safety, and the capacity safety. So we can easily click around in the job and find out all of the parameters we've entered. So for the current one we just submitted, we can see at what time we ran it for, and for how many hours, in addition to the owner is and comments and failure scenarios and our change request commands, logs, and result details. One really useful piece of this is the cut check safety, SPOF safety, and capacity safety. Cut check safety indicates whether the changes you made to the network topology will partition the network into two disjoint pieces, or two distinct disjoint pieces. SPOF safety, or single point of failure safety, indicates whether you're at risk of cutting the graph into two, partitioning it into two separate parts. In other words, if removing one router or link could create a cut check safety failure, your SPOF safety is going to fail and become red. Finally, we have capacity safety, which indicates whether any hot links were added. For the core network type, a hot link is defined as a link in which the link has 85% or more demand, and for SWAN, 95% or more demand. These are really useful metrics to see what's going on with the change sets you applied to the network topology. Now I'm going to hand the presentation over to Nick, who's going to show you some of the new visualization features of the tool.
Now let's jump into the visualization part of ROC web app. Just click this page. You can see you can upload the WCF result file to do the visualize. Or you don't have any idea about what this file is, you can just go back to my jobs page. Hover over the results cell, you can see a drop down and go to the visualization page. We will load the result file data for you. Just wait a few seconds. You can see the visualization of the data. What I usually do is I usually go to the job information to grab the basic idea about this job. In this job, the day range starts at June 12th, 18 o'clock p.m. UTC, and the day range window lasts for 4 hours. And in this job, I removed 2 links and 1 router. These 2 links are from the region PR01 to Melville and the LAX to the Honolulu. And the PR01 router also be removed as well. So go back to visualization page, we can see links and the nodes on this map. So nodes here stands for a region. You can zoom in to see the region name on the nodes, and once you click in, you can see all the router inside this region. Just Let's reset the view. You can also see their links have different colors in this map. The red link here means the link at this specific time point has changed become from not hot to hot. The orange one means the link has the utilization change more than 20, and the green link means this link has changed is changed from hot link to not hot, and the remaining link is marked as blue. And at the top of the map, you can see a play bar. You can drag the blue dot to stop at any timestamp you are interested to see the utilization change. Also, you can click on the link to see the utilization change of that specific link. You can click the play button to see how the utilization change over the time inside the timestamp. This also works for the single rotor. You can just click on any rotor you are interested to see the incoming and outgoing utilization change over time inside the date range. So this is how we use data visualization for hot links, and we'll keep adding new features and support more data types and improve usabilities for this visualization feature of ROC. That's it.